Hello everyone, welcome to our today's session. Today we are going to continue about the programming part of Verilog. We are going to use EDA Playground website for the purpose of programming Verilog designs. So, like in lab, we use Xilinx. Xilinx software is very huge in size, like above 4 GB, and many students, due to lockdown, they are not able to access the system with high configuration, and they are not able to use the Xilinx. So, we are using this alternating website. So, what we have to do, we have to simply type EDA Playground, and normally we get it at the first link. After once we type it in Google, then we have to click on EDA Playground Edit Code. So once this site is loaded, we get screen something like this. There are two parts. There are two windows. So two windows are used for writing two parts of our program. All of us, we have discussed in initial section that we need to write a design part and a test bench part. So these two windows are used to type the design and test bench. The difference is that both the windows we can access, we can type in between them, but the design part will be simulated first, and after simulation of design part, test bench will be simulated. So we can share the programs, we can type the programs. At bottom we can see that there are options of mailing our program. Now this EDA Playground is not meant only for Verilog, but there are various platforms which we can use using single EDA, like we can use VHDL, or we can use Python, or we can use C++. Like that, there are various options which we can use for programming, but our concern is about Verilog. So we will use system Verilog option out of all the options, where we will get test bench plus design. So that is the main feature of Verilog, where we have design as well as test bench. Along with that, there are other parameters at left side, like libraries. For there are predefined libraries in Verilog also, like we may have in C language or any other language. So we have various libraries. Whenever we require these libraries, we can select from here. There are not this website doesn't include all the libraries, but the libraries which are available are sufficient for our practice purpose. So then once our typing is done, we can run and check the errors. And after checking errors, we can check the waveforms, output waveforms. And the output waveforms are not analog here. Our output waveforms are in terms of zeros and ones. This EDA Playground also supports various examples. Predefined examples are loaded and simulated for verification purpose. So once we click on the Verilog example, we'll get a list of programs where Verilog programs are already dumped for the user. So let us check one, like say we have D-Flipflop or RAM or finite state machine. Let's check for D-Flipflop. We know for D-Flipflop there are three inputs and two outputs. We give reset, clock, and our D as input, and at output side we get Q or Q bar. So let Q and Q be the outputs, and D reset be the inputs. So here we can see we have a program. Now you can see in the programming, in design part at right side, we define, say, module name we are giving as DFF, that is D flip flop. In bracket we are declaring the inputs and outputs, say CLK clock, reset, D are our inputs, Q and QB are the outputs. After that, again we have to declare the input and output. So we are defining precisely: input is clock, input is reset, input is D, output is Q, and output is QB. Then we are defining register as Q. Once we done all of it defining the inputs, then our programming start. So we are defining register as Q, and we are assigning QB as not Q. That means whatever value is on Q, it will be inverted on QB. If Q is 0, QB will be 1. Then in this particular style of programming, always keyword is used. So by using always, we are defining the input and output. What are the types of input? What are the types of output? For writing one program, there are so many different kind of methods. So we can choose any method for writing our program. This is about design. Then we have to write the test bench where we define when to start the input and when to start the output. So the delays and initial is the main statement used in the test bench, and both of them they ends with end module, both the parts. So on one more difference, in test bench we use register reg for defining inputs, and we use wire for defining outputs. All of us must remember this, because all the program will have same kind of syntax. So once we define everything, then we can check the output. We have to define the output type, whether it is hex output or binary or any other kind of output. So we have seen them in the data types. With end module we can end it. So like this we can use this particular test bench. So this D-Flipflop, we can write both the parts and we can use them. Now to access the programming, we have to log in. So once we click on the login, we get a window like this. We can log in by using Google or Facebook. Let us select Google. Then on Google we may have our account. We can select we are logged in. We will get a window where our profile will be there. We can write and save and share the programs. So we have to use these two windows, and we have to write the programs, and we have to check the outputs. So here we can also check our profile. If we click on the profile, then our profile will be visible. Just now we have created, so we will not have much data here. So we can check profile, or we can also log out from this particular place. Now by using these two windows, we can type our program. We can extend the windows as per our convenience. So both the windows are used for typing our requirement. Here right side we type design, but the sequence of simulation will be like the design part will be simulated first, and after that test bench will be simulated. So if we want to write some program for some display, so for displaying, so we can give some module, say module test. Now let us check out an example for writing a module. So when we write any program in any programming language, we have to take care of syntax. We can commit small mistake and we will get the error. Our program may not run properly if we commit mistakes. So let us check one example where we will do some mistakes and find out how to correct them. So here let us write a program to display something on the board. So we are giving name module test and initial begin, and for display we are using $display. In classes we have discussed the meaning of this particular keyword. So let us display something like welcome to online session by Dr. Soil Rana. So this is my simple statement I want to display on the screen at the output. So output we can check at the bottom once we run it. So let us just save it and check how we get. Before doing that, we have to end our program and we have to end module. Now in this program we have kept few errors so that we can check out how to find the errors. If we directly write a program errorlessly, then you may not get a clear idea. So I kept few mistakes here. So let us now just check it. So we have to select the simulator. Before that, at left side we have some options for uh, adding particular sections. So this, the first part is say other libraries. We are not including libraries here in this particular program. We don't need library. We need some simulators. So we have one option called tools and simulators here. So there are various options for selecting the tools and simulators. If we click here, we will get the simulator list. So let us select Icarus Verilog 0.9.7. This standard we will use for this particular program. We need a simulator to for the simulation purpose. So we have a program. We have to select a simulation tool from this tools and simulator. We will click here on the Icarus Verilog 0.9.7. Then we can save and run this, and let us see how we get the output. So let's run it. So if we directly run it without saving the name, it will take default name. Now here you can see we have some errors. So test bench, we have syntax error and we have other errors. So we can check here the line by line what are the errors. So first error related to syntax, and say we have in line 5. In line 5, if we see, we have given the colon, semicolon. We don't need that. That's why we are getting our first error. The next is saying for line, say next line 10. In line 10 we have end and end module. So here we will just take it back. Okay, this is our end module. We have removed the semicolon. Sometime whenever is the error line given, we have to check one line before and one line next to that particular error line. So now after making necessary changes, again when we run it, we will get no error and our output will be displayed. So this is the display part of the EDA playground. Here on display we can see that the message what we have given is displayed. It states welcome to online session by Dr. Soel Rana. We are not getting the part which is given in the inverted commas here. Inverted commas won't be visible. We will get only our message displayed at the output. In similar way, we can check out the other output. Let us see how we get display for waveform test bench. So this is a display example. We will see one default example from the library, and we will see how we get the waveforms or the simulation timing diagrams in this EDA playground. Before going to that, let us see one more feature of this particular EDA playground. We can copy the link what we have saved. Our program can be saved and we can share it with someone else. And if we copy it to some new window and just click it, then we will get our programming code. So here we get various options, like you can see here. We can share it through Facebook or Twitter, and your friends can check out your program, and you can help them to you can correct the program and share easily with your friends on the social media. This is also one good feature in this EDA playground. So here at bottom we can share it after running So we can click open EP wave if there is waveform involved in our program, but here we are not using any waveform, and supporting file is also not included, so we will not get any waveform for this particular display program. But for sharing, if we have to share it, here you can see we can give the description of our program along with our message. There is a place for drafting mail at the bottom where we can give details. Now let us go to some examples, and we will check some waveform, how we get waveform. So we'll go to Verilog program list. The list will appear. Let us take example of RAM. So predefined, preloaded program is available in the RAM. As an engineer, you have to design various portion in given task. Maybe you are working in a team and you are designing a processor. Someone will design RAM, someone will design ROM, someone will design CPU. So all those programming you have to design and embed together. So there you will write a test bench and design in Verilog. So you have to read data, you have to write data, and you have to keep on doing that in this particular section. So once you have the supporting files for the output waveform, then we can check its waveform, how our input is given, and how we can check the output waveforms for read and write instructions related to RAM. So what we have to do, we have to select open EP wave after run. So here at left side we have this option at the left bottom. Here open EP, we have to write click, we have to check this open EP wave after run, and then we will simply run. Once we have program which doesn't have errors, we'll get the supporting instructions and immediately we'll get a waveform. Here waveform, you can see that we have a read, write, and clock. These are our inputs. How inputs are changing, and as per input, what are the parameters changing at the output. This is our function to check. So in this way we can check out the output waveforms also. So in next continuation session we will take the example of examination, and we will type, we will check, and we will get the output, and we will see more parameters which are available in this EP wave page. Till then, have a good day.